Okay, so I can see that it is recording now. So we should have the recording at the end of the class. So, oh, thank you to remind me that. Okay, so I just share my screen. So last time we saw some command, and I want to go further with the commands. So let me open a shell. And we are going to see additional information. So every time that you execute a command, it have an exit statute. So the exit statute will be 0 if and only if the command was successful. So if you do a man of several commands, you will see that you will have information of the exit statute. So for example, last time we used the command ls, we did man ls, and normally the exit statute is toward the end. So it say if the command is successful, it will return a 0. For example, if there is any problem, it will return either a 1 or a 2 as an integer to say that there is a problem. For example, if the file does not exist, it will return a 2. So let me go to my desktop and create a file. Let's call it file01.txt. So you remember with the command touch, I create a file, it is there, and it will be an empty file. So if I do ls for listing -long file01.txt, I should have the information of the file. So those are the right of the file. This is the owner of the file. This is the group of the file. This is the number of bytes of the file, 0 byte. This is the last modification on date and time, and this is the name of the file. Now, let's say that file 2 does not exist. Oh, before we do that, how do we get the return statute? I just execute a command, and I want the return statute. So there is a variable that is called $interrogation. And this return statute will be the return statute of the last command. So the last command that I execute was the ls-l. So since it was successful, this return statute should be 0. So as you can see, it's 0. Now, if I do the same command with a file that does not exist, for example, this file that does not exist, file02.txt, I should have a warning, an error message saying that this file does not exist. So as you can see, it say no such file or directory. Say that it didn't find the file, so it cannot give me the information. Now, if I see the return statute, the variable is $interrogation, I will have a return statute that is different of 0. In this case, as we have seen, it will be 2. So every time that you execute a command and there is a problem, you can check the return statute to know what have happened. For example, let me create a directory. I'm going to create a directory. I'm going to call it AA. And of course, it's going to appear here in the desktop. So this command was successful. If I ask the return statute, it will say it was successful. Now, if I try to create the same directory, this command will not be successful because the directory already exists. So I will have an error message. As you can see, it's a cannot create directory because directory AA already exists. So if I look at the return statute, it's 1. Every time that you have a value that is different of 0, it means that there were a problem. Of course, if I do a man of make dir, it will tell me about the return statute toward the end. So here they didn't, unfortunately, the man didn't say anything about the return statute, but the return statute is every time that is different of 0, it means that there were a problem. So this is not a very good manual for this command because it should have say about the return statute. Okay. So for example, I'm going to remove this directory. I can use remove dir AA, and it will remove it. As you can see, it have disappeared from the desktop. And if I look at the return statute, it will be 0 because I could remove the directory. Now, if I try to remove the directory again, this directory does not exist anymore. So of course, the remove directory, we have an error message. And if I look at the return statute of the remove directory command, it has to be different of 0, as you can see. Okay. So I don't remember if we saw this last time. When we have several commands that we want to execute and we want to write them in one line, we can separate them with semicolon. For example, I can write make dir AA semicolon, for example, ls dash long. So what will happen here? It will first create the directory AA, and then it will show me a listing. In the listing, we will have what? So we will have this file, 501.txt, this one that is called add2integer.py, and we will have the AA directory because I just created the AA directory, no? So let me execute that. As you can see, the AA directory was created and I have a listing. There is another file here, so it should be hiding in some part, or it is there. Okay, because I can see that in the listing there were an additional file that is called add2integer.bash, so it was hidden by the terminal that is there. No, so I did the two command. And the exit statue of a compound command like that will be the exit statue of the last command. So in this case, it will be the exit statue of the ls, which is 0. So if I ask what is the exit statue, it is 0. So tell me what will happen if I do that. Make dir bb, make dir AA. What will happen if I do that? So it will execute the first command, which is make dir bb. It will do what? It will create a directory that is bb. Then it will do the second command, which is make dir AA. The directory already exists. So it will show me an error message. And what will be the exit statue of the whole command? Will it be successful or will it be unsuccessful? So it will be the return statue of the last command. The last command is unsuccessful, so it will be unsuccessful, no? This one is successful, and this one is unsuccessful. But when you concatenate command and separate them with semicolon, the exit statue of the whole command will be the exit statue of the last command. So it will be something different of 0 because of the make dir AA that cannot be performed. So as we can see, it creates the bb directory, and it did complain that the AA directory was already existing. When I look at the exit statue, it's different of 0, saying that the last command that were there did not succeed. So let me do something different. For example, here, let me do remove directory, and here, let me do a make dir bb. So bb already exists, it's going to be erased. Then I'm going to remove the directory AA. Sorry, bb already exists. Since I'm creating a directory, I will have a warning. So this command is not going to be successful. Now the second command, since the directory AA already exists, it's going to be removed. So the first command is unsuccessful. The second command is successful. Since the result, the exit statue is the exit statue of the last command, it will be 0. Okay, because the remove directory AA will work. So let's do it. So we do have a message saying that we cannot create a directory bb because it already exists. It is there. We can see that the AA directory did disappear. So we remove the directory. And if I ask for the exit statue, it will be 0, which means that the most right command was successful. Okay. So another way to create a compound command is separate the command with ampersand ampersand. So you put command 1, ampersand ampersand command 2. So what will happen when you do that? So first, it will evaluate command 1. If command 1 fails, the whole command will stop there. And the exit statue will be the exit statue of command 1. Now, if command 1 is successful, it will evaluate command 2. And the exit statue of the whole command will be the exit statue of command 2. So let me write that. So it's maybe easier for you to understand. Let me open Paint and see what will happen if I execute a compound command that have ampersand ampersand. So we have command we have command 1 ampersand ampersand command 2. So first we will evaluate command 1. So command 1 can fail or command 1 can be successful. So let me put the case of successful here. Successful and fail here. So if it's successful, can we already say what will be the value of AND if the first operand is true? Do we need to evaluate the second one to know the result? Yeah, we do need. If you do true on something, the result will be the value of something. So you do need to evaluate the second operand. So if the first command is successful, I'm going to evaluate the second one. So I'm going to evaluate command 2. So if command 2 fail, the whole result will be fail. And if command 2 succeed, let me just write success, we will have a success. So this is what we are going to execute. So look, we execute command 2 if and only if the first command is successful. Okay, because we need to evaluate the second command to tell if the whole command is successful. So the command 1 and command 2 will be successful if and only if both are successful. But we have a shortcut. As soon as command 1, we know that command 1 has failed, we don't even evaluate command 2, as you can see, no? Look, if command 1 have failed, we don't evaluate command 2 and we know that the command have failed. And that's it. Okay, as we have the AND, we have the OR. So let me explain you the OR, how it's work. So we will have command 1 or with pipe command 2. What do you think we are going to do here? So first we do command 1 and then what do you think? It can be successful or it can fail. So let's put the fail here. If it's fail, what do you think we should do? And if it's successful, what should we do? Okay, if it's successful, we are done. We know that the OR is successful. So if it's fail, we have to evaluate command 2. So we are going to evaluate command 2. And if command 2 is successful, the whole command will be successful. Now, if command 2 fail, the whole command will fail. Okay, this is the way that it works. So let's see some practice about that. So before we do that, there is a way to compare two integers with the shell. So there is a command that is called test. Let me do a man test so we can see this command. So look at, we are going to write test and an expression. Or also we can use, instead of test, an alias or a synonym of test is square bracket, and an expression and square bracket. So when you want to test, you can use parentheses. If you want to do a not, you use the exclamation mark. If you want to do an AND, you do a -A for AND. If you want to do an OR, you do a -O for OR. Now, if you want to compare integer and you want to test if they are equal, you use the -equal, -EQ for equal, greater than or equal, greater than, less than or equal to, and less than, and not equal. So it's the way that we can compare integer. So let's see that. Let me do a test. For example, I want to test if 12 is equal to 12. So if I want to compare if 12 is equal to 12, I have to write something like that. Test 12 equal to 12. So of course, this is true, which means that the command will be successful. So the exit status must be 0. So look at the exit status is 0. Now let me ask if 12 is equal, for example, to 34. This is false. So if I ask the exit status will be something different of 0 because this command failed. You see? Okay, let's see, for example, let's ask is 12 is less than 34. So 12 is less than 34 is true. So this command is successful. So the exit status must be 0, as you can see. Now let's ask if 12 is less than 12. This is not true. So the exit status should be different of 0. Now let's ask if 12 is less than 3. This is not true. So the exit status should be different of 0. Okay. Now let's that if 12 is less or equal. That will be less or equal. 12 is less or equal to 23. This is true. So the exit status must be 0. Now let's ask if 12 is less or equal than 12. This is true. The exit status must be 0. Now let's ask if 12 is less or equal than, for example, 67. Sorry, let's put something smaller, like 7. It will be false. So the exit status have to be different of 0. Okay? So if you want to do the not equal, for example, 12 is not equal to 7, this will be true. Not equal. So the exit status have to be 0. If I want to ask, for example, greater than, 12 is greater than 7, this is true. So the exit status must be 0. So another way to do the test command, as you have seen in the man, let me do the man test again, is instead of using the test command, you can use a square bracket and finish the expression with square bracket. So let me do the same thing. Let me do the same thing. Square bracket, for example, 14 not equal to 45. This is true. So if I ask the exit status, it have to be 0. And it is 0, as you can see. Okay. Now let's see the AND. Let's say that I want to say, for example, 14 is not equal to 45. This is true. And for example, 12 is equal to 12. So this is true, isn't it? So if I ask the exit status, it have to be true. So it have to be 0, as you can see. Now, for example, if I put 12 is equal to 13, the first part of the AND will be true, but the second part will be false. So true and false will be false. So the exit status have to be different of 0, as you can see. So if you want to use parentheses, you can do. So for example, it might be a little clearer if you put parentheses here and parentheses here. Okay, so we see exactly what we are doing. For example, we are comparing 14 to test if it is not equal to 45. And here we are comparing 12 is less or is not equal. Is equal, sorry, to 13. Now, when you use the parentheses, you need to escape them. So if I want to use the parentheses, I need here to escape them with backslash. Otherwise, it will not work. So let me escape this parenthesis, the open parenthesis, and this closed parenthesis. And the result will be, as you know, it will be false. So since it's false, the exit state you have to be different of 0. Let's do an OR. If I do an OR of that, the exit state will be true. Why? Because this is true. The first part is true. The second part is false, but true or false is true. So the exit state must be 0. Okay? And if I want to do a NOT, I can do a NOT. So let's do a NOT, for example. So for example, this by default, well, I don't need a parenthesis to tell you the truth. So I can just do that. 14 is not equal to 45. That will be true. So the exit state must be 0. Now, if I put not 14 is not equal to 45. So 14 is not equal to 45 is true. Not true will be false. So the exit state must be different of 0, as you can see. Okay? So look what we can do. You see this expression that we did here? There is other way to do it. So for example, I can do this. To do an OR. So look at this expression. Here we are doing a test and we are comparing if 14 is not equal to 45. Then we have an OR, then we have another test. So what about this test will be true or false? Will it be successful or it will fail? It will be successful, no? It's not equal. So are we going to evaluate that? Are we going to execute this command? So according to what we wrote here, if the first command is successful, we are done. So we are not going to evaluate that. And we know that the whole command will be successful. So when we look at the exit state, it will be 0. But look here, we have not evaluated that. Okay? We have just evaluated the first part of the statement. I can do, for example, what will happen if I do that? This is an AND. So we first evaluate the left operand. 14 is not equal to 45. This is successful. If this is successful, what can I say about the AND? I need to evaluate the second part to know if the whole is successful, because you need successful and successful to be successful. This is the only way you can be successful, that both are successful. So if the first one is successful, I do need to evaluate the second one to see if it's successful. And if the second one is also successful, the whole result will be successful. So the second one, 12 is equal to 13, is not successful. So the whole result will be fail. It will be unsuccessful, no? So look, if I look at the return state it has to be different of 0. Okay? Okay, so let me see. There is a new version of this command, the square bracket command. We can use double square bracket. So double square bracket is a little better because when we need parentheses, we don't need to escape them. In single square bracket, which was created much earlier, when we use parentheses, we need to escape them. So for example, look, I'm going to use this and put parentheses. For example, 1 is greater than 12. So when I execute that, it will complain because I didn't escape the parentheses. So look, it say there is a problem near the token 1. So the problem is this guy. I need to escape this guy. So let me do it the same thing. I'm going to escape the parentheses and escape the parentheses and redo it. There is no problem. And of course, the exit state will be what? 1 is greater than 12 is false. So this command has failed. It have to be an existential that is different of 0. And is different of 0, as you can see. Now, if I use the double square bracket, I don't need to escape the parentheses because it's a newer version. And in the newer version, they say we don't need to escape the parentheses anymore. So for example, I can do that. And it doesn't complain. And the existential, because it is false, will be different of 0, as you can see. So in the new version also, when you want to do the AND, you don't have to do -A. You can do -A if you want. Okay, for example, I can do -A and put, for example, a second condition. So let's put, for example, 13 is less or equal than 14. So what can we say about that? 1 is greater than 12 is false. So we have false, and whatever we want, it will be false. So this, oh, it does force me to do it. I thought it will allow. Yeah, it does force me to do it. So the square bracket don't like the -A. It does force us to put ampersand to do an AND. So we just did an AND here. And what will be the existential? So the first operand is false because 1 less than 12 or 1 greater than 12 is false. So the whole will be false. So the existential have to be different of 0, as you can see it. Okay. There is even something much better, which is double parenthesis, which came after historically. So with double parenthesis, I can do that. 12 is less than 12. So it will say no. These are fail, which means that it will give me an existential that is different of 0. So I can say 12 is less than 12. So this has to be true, less than to equal. If I ask 12 is less than or equal to 14, this have to be true. So the existential have to be 0. If I ask 12 is greater than 14, this have to be false. So the existential have to be different of 0. Okay, so we talk about existential. Okay, let's do a program that read 2 integers and show the minimum value and the maximum value of the 2 integers. So let me create a program that I call test.bash with my favorite editor, but you use Nano if you are not familiar with VI, because VI is pretty complex, no? So you better use Nano. So I'm going to type the hash bang. We saw that last time, saying that what I'm writing here, I want it to be executed by bash. And the path of bash is /bin, /user, /bin, /bash. Okay. So I want to guide the user, and I want the user to enter a first value. So what should I write here to show a message on the screen? I can use the echo command, no? Echo -n. We saw that the -n is to tell, don't go to the next line, stay there. So enter the first value, the first integer, let's put. Okay, and with read, we are going to read in a variable that is called v1. We are going to read the first value. Okay, then we need to do the same thing with the second value. So here, I'm going to copy these 2 lines. And here we are going to put enter the second value, the second integer, and we are going to read it in v2. Now I want to show the minimum value of v1 and v2. What can I do? So I would like to write something like that. Command 1 and command 2. So what can be command 1 and what can be command 2 to show the minimum value, for example? So I can compare the value of V1 and check if it is less or equal than the value of V2. What happens if this is true? If the left operand of the ampersand is true, what can we say? Who is the minimum value? Is V1 or is V2? If this is true, the left part, the test that I'm doing here, if this test is true, what can I say? V1 is smaller, so the minimum will be V1. So what can I do here? I can just echo the minimum value is, and I'm going to show the content of V1. So now, is V2 is less than V1? Who is the minimum value? The minimum value will be V2. So this program will show me the minimum value. So let's execute this program. So I'm going to go here. Let me go inside the desktop directory. I'm going first of all to make the new file executable. So user plus X, change it to an executable. So it's called test.bash. And now I'm going to execute test.bash. So it's asked me for the first integer. Let's put 56. On a second integer, let's put 77. And it said the minimum value is 56. Correct, the minimum value is 56. Let's execute it again. Let's put, for example, 90 here and 22 here. The minimum value is 22. That's correct. Let's put 22 and 22. The minimum value is 22. And that's correct. So it does work. So look at what we have done here. What will happen? If this is true, I will execute this. So let's say the first case that we enter 56 and 77. If V1 is 56 and V2 is 77, what can you say about this test? Is it true? Is it successful or is it a failure? It will be successful. Since it is successful, I need to execute this one. So I'm going to show the minimum value is 56. Now I also execute that. So V2 is 77. So 77 is less than 56. Is true or false? It's false. So this will be a failure. If this is a failure, what can we say about the AND? We can stop. We don't have to execute the right operand. So we'll not execute that. So it's why when we enter 56 and 77, it did execute this, but it didn't execute this because this part was false. If this part is false, the AND will be unsuccessful. Okay? For AND to be successful, both operands have to be successful. So if the first operand is not successful, I don't even evaluate the second operand. Is it okay? Okay, if I want the maximum value, what should I do? So I should just change a little my program. So if V1 is greater or equal to V2, the maximum value will be V1. Is V2 is greater than V1, the maximum value will be V2. Okay, so with that, we will have a program that will show us the minimum and the maximum value. So let me execute it and we'll see it in action. So it asks me two values. Let's put 12 and 56. So it says the minimum value is 12 and the maximum value is 56, which is correct. Let's put, for example, 42 and negative 90. So you say the minimum value is negative 90 and the maximum value is 42, which is correct. Okay. So we also have some statements in the programming in the script in the bash. So let's see the statement that we have. So we have an if statement. How are we going to use the if statement? So there is a keyword that is called if. So we put if, and here we put a list of statements. So if this list is successful, then, which is a keyword, we execute all the statements that are here. And phi is the end of if. So as you can see, phi if backward. So if the list of statements is successful, I will execute all the statements that are inside the if. Okay, let's see a if else. So this is a first possibility. Let's see the if else. So you have a if, you put a list of statements, then what you want to execute if the list of statement is true, else what you want to execute if the list of statement is false, and phi. This is the end of the if. So you first execute the list of statement. If the list of statement is true, is successful, I should say, you execute this list of statement and you come here. If the list of statement is unsuccessful or fail, you come here and execute this list of statement, and then you are done with the if else. So remember, the list of statement must end with a semicolon. Okay, to say there is no more statement in the list of statements. So you must end it with a semicolon. Let's see a if, else, if. We can do that also. So which is nested if. So you can write if a list of statements. So let me write list 1 to make it a little clearer. Then what you want to execute if list 1 is successful. Else if. So it's a keyword. Then you have another list of statements. Then the list of statements that you want to execute if this one is unsuccessful and this one is successful. So you can have as many else if as you want. Else if a third list, semicolon, then, okay, blah, 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 blah. Let me put else if list n, then what you want to execute, phi. So what will happen when I execute this statement? So first, I'll evaluate the list of statements here, list of statement 1. If it's successful, I evaluate the statements that are here and I'm done. I go after the if. Now, if the first list of statement is unsuccessful, I'll evaluate the list of statement 2. If this one is successful, I execute all the statement of list 2 and I'm done. Okay? If list 1 is unsuccessful, I try list 2. Let's say that list 2 is also unsuccessful. I try list 3. If list 3 is successful, then I execute the one of list 3 and I'm done. So you try them one at one. You try the first one. If you have a success, that's it. You execute all the statements that correspond to the first list and you are done. If the first one does not work, you try the second one. If the second one does not work, you try the third one. You try to find one that works. the first one that works, you execute the list of statements that are inside this else if, and you are done. So of course, we also have the same one with a final if, with a final else at the end. So we have also this one. We have if, so you have a first list that you try, then if it's work, you execute this statement. Else if it's only one word, you have a second list. Then if it work, you do this. If the first list, the second list didn't work, you evaluate the third list. And if it works, you evaluate that. Let's say that none of the lists have worked. So here you have list N, then, and let's put an else here, and a phi here. So what will happen? If the first list is true, I do that. If the first list is unsuccessful, but the second is successful, I do that. Let's say that list 1 was unsuccessful, list 2 was unsuccessful, up to list N. All of them were unsuccessful. I will come and execute the else part. Okay? If all of them are unsuccessful, I do the else part. So let's go back to our exercise. This time, I want you to read 3 integers. So I want to modify this program. I want to read 3 integers and show the minimum value of the 3 integers. So what should we do here? So I'm going to read a third integer. Let's call it V3. And what can we do to show the minimum value of V1, V2, and V3? So of course we can do if, the one that we just see. So give me an example. Let me, since we are going to do several solutions, let me put a separator between each solution. So between this and this, we will have the first solution. So let's do the first solution here. What can I do? I want the minimum value. So I can ask if V1 is less or equal than V2, and V1 is less or equal than V3, the minimum will be V1. So I can say if, how do I write that? For example, so I can write, for example, parentheses $V1 is less or equal than $V2, which means the value of V1 is less or equal than the value of V2, and the value of V1 is less or equal than the value of V3. So if this test is true, look, I put a semicolon at the end. You remember, if list of statement, there is only one statement, then what can I say if this is true? What can I say? Who is the minimum? V1 is the minimum. We are saying if V1 is less or equal than V2 and V1 is less or equal than V3, so the minimum is V1. So I can echo the minimum value is, and I'm going to show the value of V1. Okay? Okay. What should we do after that? I can write an else if. If I arrive here, what can I say? If I arrive to this else if, who can be the minimum? V2 or V3, but V1 cannot be the minimum anymore, because if V1 were the minimum, I'm already outside the if because I execute the previous command, the previous echo, saying that the minimum is V1. So if I execute this part, the minimum have to be either V2 or V3. We don't know. We have to test. So it's why I say else if. So I'm going to test if, for example, the value of V2 is less or equal than the value of V3, semicolon to say that there is no more command in the list of command. What should I do? If the value of V2 is less than or equal to V3, what should I do? Who will be the minimum? V2 will be the minimum, so I'm going to say the minimum value is V2. And if I arrive to this else, what can I say? The minimum value have to be V3. It cannot be another value, because if it was V1, I will have execute this command and I'm gone, I'm done. If it was V2, I will have execute this command and I'm done. So if I arrive here, it have to be V3. So look at, I put a phi here. So this is my first solution. So just to see that it works, let me execute it. So we are going to execute the test program and it asks me three values. Let's put 12, negative 19, and negative 77. What is the minimum value of this list of three integers? Negative 19, the one of the middle. And as you can see, say the negative value, the minimum value is negative 19. So what about this one? If I put, for example, negative 12, 89, and 22, who is the minimum? The first value, which is negative 12, okay? Not the middle value like previously. So when the first value is the minimum, it's work also. Let's see when we put the minimum as the last value, it have to work also, like V3. So let's put, for example, 56 here, 90, and for example, 3. So the minimum value is 3, which is the last value, and it did work. Okay? So give me a second way to do that. But this time, instead of using the square bracket, I want to use, for example, the square bracket, the double square bracket. What should I write? I'm going to copy the 7 line here, and I'm going to modify them. So I don't want you to use the square bracket, but the double square bracket. So when we use the double square bracket, we don't need to escape the parentheses. So let me do that. And the and is with ampersand, ampersand. I don't need to escape the parentheses, and that is, okay? So let me also end it with double square brackets. And here I want to use also the double square bracket. So I'm going to start it with double square bracket and end it with double square bracket. So this is another way to do it. Let me execute it and it will work. So let's put 12, 34, 67. So the minimum value is 12. Both cases say 12. Let's put, for example, 67, 11, 90. The minimum value is 11, is in the middle. Let's put the minimum value as the last value. So let's put, for example, negative 34, negative 12, and negative 77. The minimum value is negative 77, which is the last value, and it did work. Okay, let's do another solution. Let me copy that. 1, 2, 3, 4, 5, 6, 7 line. So 7 YY, and with P, I copy it. Okay, so this time I want to use the double parenthesis to do the AND, to do the test. So I can put double parenthesis, less or equal is like that. The AND is correct. Less or equal is like that. And here I use the double parenthesis, which is the most modern of the three one. If I want to use the double parenthesis here, I use the double parenthesis, and I want to do a less or equal, I do it like that, less or equal. So it's more similar to the syntaxis of C, as you can see now. What we put in double, oh, by the way, when we use the double parenthesis, we don't need to put the dollar to say value of 1, value of V1 or value of V2. So we remove all the dollar sign here. We just need to put V1. It will be value of V1. It will not be V1. It will be value of V1. Okay, let me save this and let's execute it another time. So 12, 45, 100. The minimum is 12. It did work when it's at the first value. Let's put 19. Let's put 14 on 100. So the minimum will be 14. It is in the middle. It did work. And let's do a third case where the minimum is the last one. So for example, 89, 0, and negative 12. The minimum value is negative 12, and it did work. So let's do another case. Let's do another possibility. What can you tell me? Give me another possibility. I want to do myself the nested if. You can do yourself the nested if. So for example, I can say what? If so, if $V1 is less or equal than $V2. Don't forget the semicolon. Then, okay, if I come here, what can I say? Who can be the minimum value if I come here? I will put a else here. And we can say something different here. And then a fee. So if I execute this code, what can I say? Who can be the minimum value? V1 or V3. It cannot be V2. Do you understand why I say it can only be V1 or V3? Because if this is true, V2 is not a candidate anymore to be the minimum value because V1 is smaller than V2. So if I come here, the candidates are V1 and V3. So inside here, I can do a if. So let's do a if to check between V1 and V2, who is the smaller one. So I can do $V1 is less or equal than $V3. Semicolon to say there is no more. So look at this else and this fee. This else is associated with this if. So if I come here, what can I say? Who is the minimum? And if I come here, who is the minimum? So if I come to this here, who is the minimum? V1, of course. So I can say the minimum value is V1. Let me copy this line so I don't have to type it. Okay, if I come here, who is the minimum? V3. Okay, so here I'm going to put the minimum value is V3. Now, if I come here, what can we say? Who can be the minimum value? V2 or V3? V1 cannot be the minimum value. Why? Because if we come here, this means that this is false. If this is false, what does it mean? That V1 is greater than V2. If V1 is greater than V2, V1 is not a candidate anymore to be the minimum value. So the minimum value will be between V2 and V3. So let me copy this 5 line and put it there and just modify them. So we know that the minimum value will be between V2 and V3. So we compare V2 and V3. If V3 is less or equal than V3, the minimum value is V2. Otherwise, the minimum value is V3. Do we agree? So this should work also. So look at, here we have a if else. Inside the if, we have a nested if else. And inside the else, we have a nested if else, as you do in any programming languages, no? Okay, so let's execute that and verify that it works well for all the cases. So if I put the minimum value at the beginning, let's see that it works. Okay, all the cases say that 12 is the minimum value. If I put the minimum value in the middle, let's see that it works. It did work. 8 is the minimum value. On the last case, if I put the minimum value as the last value, it does say that the minimum value is 0. Of course, if you put 12, the minimum value is 12. If you put 12, 13, 13, the minimum value will be, let's put 12, 13, 13, the minimum value will be 12. Does work, no? It has to work in all cases, of course. Okay, so let's see now how we are going to do a loop. So there is several ways to do a loop. So I'm going to show you some of them. So you can do, for example, a for loop. There are two ways to do a for loop. So you can write for a variable name in, and here you put a list of value. List of values. Semicolon. Do what you want to repeat several times, done. This is the first way to do a for loop. There is another way that is very similar to C++ or C. So you write for parenthesis, parenthesis, an initialization part, semicolon, a test to keep looping, so a condition. While this condition is successful, I keep looping. And you have here an update. From one pass to the next pass, you update. Semicolon, do whatever you want to repeat several times, done. This is another way. And you have the while loop also. So you can write while a list, do whatever you want to repeat, done. So while this list is successful, I keep doing the while. I keep executing the command that are in the while, in the body of the while. Okay, there is also until. Few people use it, but there is until. So you have a list here. Do, done. So do, until, done, while, for are reserved word for the bash. So if in the case of the until, we evaluate the list. If the list is unsuccessful, we keep going. So we are going to go outside the until when finally the list is successful. Until the list is successful, I have to keep going. Okay, so if the list fell, you keep going. You wait for the list to be successful, and when it's successful, you go out of the until. So it's work like that. Okay, so let's see. Let me do a program that will show the integer between 1 and 5. So let's remove all this. And let's do a program that shows the integer between 1 and 5. Give me an example. What can I execute to show the integer between 1 and 5? So I can just do echo 1, 2, 3, 4, 5 because there are so little, so the number of value is so small. I don't need a for loop to do that. So I can just do that. Okay, that's the correct solution. Give me a solution where we use a for loop. So let's do the for loop, the first for loop that we saw. So you put a for, the name of a variable in 1, 2, 3, 4, 5, semicolon, do. And here, echo, don't go to the next line, the value of I, following by a space. Done. And after that, we go to the next line. We do an echo to go to the next line. Do you understand that? So look at this for. The first time that I pass, the variable I will be 1. So when I execute that, I show a 1 and a space. And I keep the cursor on the same line. The second time that I pass, the I will be 2. So here I will show a 2 and a space. And I keep the cursor on the same line. So I will do that for 3, for 4, and for 5. Let's say that we did it for 5. I show 5 on a space, and I'm done with the for loop. So at the end, we have an echo. This echo will say go to the next line. So we don't have the, let's say that I don't put this echo. Let's say that I remove this echo. What will happen here? That the line of dash, 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 dash will be after the 5. Let's execute this command. You see the second solution? Since I didn't put the echo, the line of dash, dash, dash is in the same line. So I'm going to put an echo at the end, which echo alone will go to the next line. Okay, let's do another for loop. So for example, I want to use a for loop with parentheses, parentheses. So you can do for. So you have an initialization part. Let's call the variable I. I start in 1, no? I start in 1. I want to stay while I is less than or equal to 5. And I go by increment of 1. The same syntax that you will use in C++. Semicolon, don't forget the semicolon, do, and done. So what should I do inside? I show the value without passing to the next line. So I show $I and a space. And at the end, I go to the next line. So this will also show the integer between 1 and 5. Okay? Let me show you another way to do it. So with a while, for example. Help me with the while to see if you understood. What should we write for the while? For the while, before we do the while, let me introduce some way to do some arithmetic on integer. Oh, we saw that, EXPR. We saw that, no, last time. So we know how to do it. We know how to add 1 to a variable, for example. So let's do the while. If you do the while, how many variables do you need? You need a variable that will control the while loop, no? So this variable is starting 1. And what should I do? While this condition is true, do, done. So what will be the condition? While $I is less or equal than 5, isn't it? while $I is less than 1.5, what should I do? I should show the value of I. What else? I need to increment I by 1. What will happen if I don't increment I by 1? I will be an infinite while loop, and it will show one space, one space, one space, one space, because you never change the value of I. In the for loop take care here of incrementing I. I need to increment I. So what should I write to increment I? So let's say here I define a variable v1. There is 10 inside. What can I type to have 11? I need a command that will increment, add 1 to v1. So you know the expr. So you can do expr $v1 plus 1. It will be 11. So now I need to put that in v1. Because if I ask what is the value of v1, the value of v1 is still 10. I have not changed v1. I use the value of v1. So here with expr, I say, give me the value of v1 plus 1. So the value of v1 plus 1 is 11. But v1 is still 10. So what should I do? So v1 is equal v1 plus 1, like that? Okay, so expr of v1 plus 1, like that. So first we need to say value of v1. Otherwise it will interpret it as string v1. We don't want string v1 plus 1. We want value of v1. So we want 10 plus 1. So remember, when we want to execute a command, we need to put it between dollar and parentheses. So I'm going to execute the command expr $v1 plus 1. And what is displayed is what I'm going to store in v1. So look at the new value of v1, 11. If I execute this command again, the new value of v1 is 12. If I execute it again, the new value is 13. So if I need to increment I, what should I write here? I will receive parenthesis, dollar parenthesis, parenthesis. And here you put the command. So expr, execute expr $I plus 1. Okay, this will work. So let's see, let's execute it and see that it shows all the integer from 1 to 5. Okay? Let's do one more solution with an until. So remember the until is until a condition. So until is like, I will keep looping while the condition is false. As soon as the condition is true, as soon as the condition is successful, I go out of the until. So what should we write here? For example, I start in 1. And we are going to write until what? Do something, done. So what I'm going to do inside is to show the value of I, to increment I, that's fine. And at the end, I want to go to the next line. Just on echo, we'll go to the next line. So what will be the condition here? What can we put? We want the condition to fail when I is 1. We want the condition to fail when I is 2, 3, 4, 5. And we want the condition to be successful when I is 6. Isn't it? When it fails, we keep going. When it's successful, we go out. So until it is successful, I need to keep going. So what will be the condition? $I is greater or equal to 6. When finally $I is greater or equal to 6, I go out. But all the previous value, which is 1, 2, 3, 4, 5, I need to keep going, isn't it? So let's do that. And as you can see, this is the until solution. It did work. Okay, there is another solution, even shorter. Let me show you this solution. We can do, for example, echo. So look at, this is a range. It will show all the integer between 1 and 5. So let me just show you here. If I do echo 1.5, if I do echo starting 10, go up, for example, to 22, all the integer from 10 to 22. Or start, for example, in -5, go up to 22. So it started in -5 and went up to 22. There is another solution. There is a command that is called sequence. It will give you a sequence of integer. So look at how we use this command sequence. Sequence of 10 will show me all the integer from 1 to 10. This time they are not on the same line, as you can see, no? So sequence, for example, start in 3 and in 8. 3 inclusive, 8 inclusive. All the integer between 3 and 8. And you can say, for example, sequence start in 3, go by step of 2 until 23. So you see, start in 3, go by step of 2 until 23. So 3, 5, 7, 9 until 23. And 3 and 23 are included. So 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. So I can say something like, for example, start in 10, go by step of -2 until, for example, -10. So we'll have what? 10, 8, 6, 4, 2, 0, -2, -4, -6, -8, and -10. Okay? This is a sequence. So what can we write here? What other solution we can write here if we use sequence? So you see all the solution that we can write. So we can write what? For I in. So instead of writing 1, 2, 3, 4, 5, I can use the command sequence. So help me with that. What should I put here? With the command sequence. I want all the integer between 1 and 5. So what will be the command that I type here? I need to type sequence of 5, no? Because sequence of 5, you can type sequence of 5. Or you can type sequence 1 to 5, from 1 to 5. Or you can say from 1 by step of 1 up to 5. Any tree solution is okay. So sequence 5 is okay. Can I write directly sequence 5 here? No. I need to say, you are going to execute a command. And this command is sequence 5. And the result is what I want here. Okay? So we will have one more solution. So look, we'll have this solution that we didn't check and another solution. So did I save it? Let me be sure that I save it. Save. I'm going to execute it. Here it is. Okay. So this is the echo curly brace 1.5 curly brace. And this is the one that have a 4 and the sequence inside. So you see, very powerful. Why we have all this? Because Unix is a very old operating system. It was there in the 17th already. So what happened is that a lot of students program their own command, and they add this command to the operating system. So for example, when you want to do the test, the first command that was there was the test command, which is very basic. Then another student some years after say, oh, the test command is too basic. Let me do a new command. And this student do the square brackets, which is much more easier to use than the square bracket command or the test command. Then another student came years after and the other student say, the square bracket is too primitive. Let's add something that is more powerful to Unix. And this student do the parentheses command. So it's why we have all this power, because historically, everything that was incorporated into the operating system is still there. So we still have very, very old command and we have newer command because new student came and programmed new command and they were accepted and put into the operating system. Okay. So let me show you another command to do arithmetic, which is the basic calculator command. So I type BC and I'm in a calculator that can perform integer operation and real number operation. So I can say, for example, what is 1 plus 3? 4. Or I can say parentheses 1 plus 3 time parentheses, for example, 4 plus 6. So 1 plus 3 is 4, 4 times 4 plus 6 is 10. So that will be 40. Okay, so you see, you can do things that are very powerful. Or you can do, for example, 12 divided by 5. What will be 12 divided by 5? This is the integer division. So it will be 2. Okay, so it will not be 2 point something. So it will be just 2. Okay, because it's the integer division. If I do 12 modulus 5, it's 2. This was not a good example. Let's do 13 modulus 5, it's 3, for example. Or 14 will be 4, no? This is the modulus. So you can even convert from one base to the other base. So you have output base. By default, it's 10. But let me put it in 2. And let me put, for example, 200. This is 200 in binary. Because I say I want the output base to be 2. So I can change it. I can put the output base in 8. And I put 200. This is 200 in octal. So octal will be what? Let's see that this is 200 in octal. This will be 3 times 64. What is 3 times 64? What is 3 times 64? 180? 180? What did you say? 192. 192? Yeah, it's 192. You're right. 192 plus 8 is 200. Okay, so this is 3 times 64 plus 1 times 8 plus 0 times 1. So this is in base 8. If I want to have it in base 16, I say the output base is 16 and I say 200. So it's C8. C is 12. 12 times 16 is 192. 192 plus 8 is 200. Okay? So it's very powerful. But look, it doesn't stop here. For example, if you want to work with real number. You can specify how many decimal you want. So for example, here I just say I want 10 decimal. Let me put the output base back to 10. And I'm going to say, what is 1 over 3? It's 0.33333, and it put 10 decimal. If I say that the number of decimal that I want is 100, let me do 1 over 3. Hey, output base is 10, and the number of decimal, sorry, is 100. Let's do 1 over 3. So here is 1 over 3 with 100 decimal, as you can see. So we can ask the square root of 2. We can ask pi. And in this case, it will be with 100 decimal. So it's a very powerful calculator. So there are different ways that I can use it. So normally, you can put all the commands that you want to execute in one file and pass this file as the input of BC, of basic calculator. But you can do other things, like for example, you can do echo on what you want to realize. And then you pass that to BC with a pipe. So for example, I want to do 10 times 7. You see in one command? So the pipe is the output of the first command is the input of the second command. So what will be the output of that? A string that have 10 times 7. So this string that has 10 times 7 is the input of BC. And when you give as input to BC 10 times 7, it's compute the result, and the result is 70. So you can do that. So for example, we can do very complex things like what we did previously, no? For example, like that plus 10. What will be the result of that? So 1 plus 2 is 3, 3 times 4 is 12, 12 plus 10 is 22. So the result will be 22. Okay? So there is another way to use BC. You use BC and you use 3 less than. And here you put a string, the string that you want. For example, 1 plus 2, and it's 3. So the less than wait a string on the right side. And this string will be the input of BC. So I can do, for example, 8 plus 1 plus 2 times 3. So 1 plus 2 is 3, 3 times 3 is 9, 9 plus 8 is 17, no? So the result is 17, as you can see. Okay, so let's see the exercises that we are going. Oh, I need to pass the attendance. Remind me that. Let me just show you the exercise that I want you to prepare for the next class. So here we have exercise 1. So look, it says write a script that reads an integer from the keyboard and show the square of the integer. So here you have an example of the execution. So the script say, please enter an integer value. Let's say that the person typed 3. It have to say the square is 9. So this one we did it. We did a sum. So in this one, you type 2 integer and you show the sum on the product. We did the sum. So do it, you add the product. This one, we did it. You type 2 integer, you show the minimum value and the maximum value. This one, we did it. You type 3 integer, you show the minimum value of the 3 integer, the maximum value of the 3 integer. So look at exercise 7, for example. In exercise 7, you type an integer like 4, and you have to show the sum of all the integer between 1 and 4, if the person typed 4. Between 1 and n, in general, if the person typed n. So 1 plus 2 plus 3 plus 4 will be 10. Okay, because 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Okay, so you have to add up all the integer from 1 up to the value that the person will type. Here you have to compute the factorial. Okay, so I need you to do that, not with Java, not with Python, but with Bash. Okay, the scripting language that administrator of a computer will use, one of the language that they use. Okay, let me go on pass attendance. So before I do that, I'm going to stop recording.